I would like to welcome you to our info webinar, which will be presented in the framework of our DYNAmore Express events. My name is Peter Vogel. I am in charge of Dynaform and all kind of applied forming applications at DYNAmore. Please make sure you have established an audio connection, either via use computer for audio, this should be the default setting, or call in by phone. Make sure your microphone is muted. Otherwise, we will hear some noise in the background. After the session, we kindly ask you to leave your feedback. A link to the survey will be posted in the chat. Today, we're going to have two presentations. The first one will be held by our special guest, Mr. Jenson Chen. Jenson is Vice President at ETA, responsible for global sales and marketing, and Dynaform product manager. Jenson will show us the new version 6.1 of Dynaform, which will be released pretty soon. Afterwards, my colleague Matthias Merten will give a live demo of how to extend the material database in Dynaform. Matthias is a longtime member of the forming team at DYNAmore, and he's in charge of all issues related to Dynaform as well as of thermal mechanical coupled applications using LS-DYNA, like hot forming, welding, laser hardening, and similar processes. Finally, the session will be closed by some final words. You're very welcome to ask some questions by using the chat. We will try to answer them after the corresponding presentation or after this event. This session will be recorded and uploaded to our YouTube channel, so you're very welcome to take a look there once more. We kindly ask you to evaluate this session. A link to the online evaluation form will be posted in the chat. It is anonymous and no registration is needed. So, Jenson, may I ask you to take the presentation rights and to start your presentation, please?
Thank you, Peter. Just give me a few seconds to share my screen. Okay. So are you guys able to see my presentation?
Yes, I can see it.
Okay. So good morning, and thank you for taking your time to join this Dynaform Express of webinar series. I'm very pleased to be here as a guest invited by DYNAmore or Peter to present our latest features and enhancement for Dynaform version 6.1, okay, which is scheduled for release in November. So we are now having a beta versions, and we are also testing it. Okay. So here's the outline for my presentation today. I will quickly go over our corporate overview, then a little bit about Dynaform background and modules, and we will spend more time in the new features and enhancements. Okay. We also have some demos. If you want to look at these new features, I can go over a demo, and then we will have a Q&A sessions. Okay. I am sorry, it seems to be some problem with my slide. I cannot bring it up. So let's see. All right. So as you know, we are in the CAE business for over 30 years. Okay. We develop our own software like Dynaform, Presys, and VPG. We also have ACP Op Designs. Okay, so currently here we have over 300 employees worldwide. Right, we have done a lot of vehicle development programs in the past 37 years in the business. A little bit about our Dynaform background. We're from 1983. We started to code some software for Ford Motor, and then we also do some work for Chrysler. And from this foundation, we developed Dynaform 1.0, in the mid 1990s. And then from there, we pick up more developments, and for the past 30 years, we developed different versions of Dynaforms. Okay, our sixth generations Dynaform 6.0 was released in 2019, and this year we have version 6.1 with more features and enhancements. So we cover different market segments for Dynaform. All right, we have customers in different industries: aerospace, automobiles, motorcycle, electrical and electronics. Even in a medical device, we have customers that's making very tiny needles, with the tubing. They do a roll form for a tubing. So they're using Dynaform to analyze how to improve the manufacturing process of tube needles. Okay. Currently, Dynaform supports 6 distinctive modules. Of course, our most popular modules are blank size engineering, where you can use it to unfold the 3D sheet metal parts and estimate the material costs. And also formability simulation modules. This is where you will estimate or identify your die design issues, including the wrinkles, springbacks, and formability of stamping parts. We also have different modules for die evaluations and also die system analysis, tube bendings, and blank and trim line development. Now let's go over to the new features of Dynaform 6.1. We implemented some basic line features for design or modification of your geometry. Okay, this includes the bridge of the line, where you can connect two curve or lines, either using the tangent options or using a straight options, where a straight line will be created by two, when using two end curve, you create the straight line. You can also extend the line. In these versions, we also provide offset surface. Many of our customers, they feedback that they need this option for them to offset the die surface. So we finally implemented it in Dynaform 6.0. And we also have different features for revolutions and also for sweeping the surface. It's also covered in these versions. So you can use our geometry managers to create surfaces. Next, regarding blank size engineering, we successfully implemented batch BSE. If you look at here, this feature will allow you to unfold and create the nesting reports, of multiple geometries, right? And then you can export this in a report format. All right, you're looking at the different setting here, okay, where you can set the initial geometry as a solid or surface or middle surface. You can pick that. All right, so you can create all these settings. And of course, you have the material settings, where you will direct our batch BSE to pull your Excel file with the material information for each stamping parts. Right? And then you can also set the type of nesting, in a table form, all right, or automatic features, or you can have a different report format. Okay. You can view your blank size batch BSE results, right? One of the feature that once it's done calculations, you can also view the results from this table. Okay, and you can customize your Excel report at the end of the batch BSE calculations. Okay, next is the format of the report. Excuse me, I think there is some lag. Okay, this is a format. So batch BSE has been proven to save a lot of time for engineers to analyze the cost of each stamping components. You know, if you have to do it one by one, it will spend hours doing this. With batch BSE, the time can be shortened by at least 75%. Okay, we have done several projects for our customers, and then they were kind of impressed with the amount of time they can save without spending so much time to create this tedious report. We also implemented the minimum and maximum width as a constraint in BSE. So this number has to be reasonable, because in the past, when we don't have this, then the blank size engineerings, we will create a width that is exceeding the ship meta's limitations. That is not practical. So we will set this as a standard width, by the industry. You can use this or set this up in the default configuration in BSE. Okay, for different kind of layout, you can have different minimum or maximum width. We also improve the unfolding of tailor water blank. All right, in the new versions, you can get both the blank as a whole or individual blank, for the welded part. Next, I'd like to talk about the spring back compensations in Dynaform 6.1. We implemented these features as a SCP, as a tab here. All right, and then you can choose either automatic or manual options when you want to set up the spring back compensations. For some older users, they might be using the manual SCP in the past, so that's why this feature is implemented here. But most of the time, we will recommend a user to select the automatic options, where the SCP will continue after a successful forming simulations. Okay, so this is the GUI of the SCP. Right, you can select your die and then set up your compensation zone, either the whole area or some localized regions that you want to choose, and then you can set the number of iterations, all right, for the automatic options. And at the end of the calculations, you will use this view results to look at the spring back compensations. Okay. This is just to show it. When you click on view the results, they can pop up a new windows where you will have a feature for you to display the contour or histogram. I have a histogram. I'm not sure why this is not shown up in, all right, the presentation here. So you can click on that to show the compensation contour or the histogram. There are also some other formability simulation feature that's being implemented in the new versions. We have more than 80 features in version 6.1. I'm listing just some of the one that I thought will be of your interest. Okay, and listed here will be a less priority for most of the users, but this might also be an interesting feature that you would like to know. We will have a display of the blank area, the weight or the volume of your blank. Some customers, they like to know how heavy is the blank. So this information will be included when you are setting up your simulation model. You can look at this information. We also support the Lobato integration rule, okay, for composite material. Okay, so you can set up this integration rule when running forming or trimming operations for composite material. User can also configure the default contact definitions, such as the frictions or the contact algorithm, is a soft options, or the eye gap and other contact parameters. You can set this up in the configuration file inside Dynaform. 6.1 also support the definition of a curve using a smooth options. Okay, it's provided in our latest versions. And then we also enhance the definition of a draw bit box to ensure that the calculation is much more accurate, okay, when you have the line bit definitions in your simulation model. Right. The local adaptivity function is also enhanced. In this case, user don't have to modify the depth of the box. In the past, you don't know where is the box located at. Sometimes your localized adaptivity fail to work because of improper box depth or box locations. In the new versions, this feature has been significantly improved. We also implemented edge stretch calculations in post-processing sites, and there are also many more features, okay, being implemented in version 6.1. Now we also have this new feature called drop test, for sheet metal transfer and handling. It's part of our DSA features, but also a request from our customers, one of the OEM. All right, they would like to know what is the deformations of a sheet metal if they are being transported from one conveyor to another conveyor, or being dropped by the robot onto the conveyor. So they like to see, if they need to modify the height or check the belt speed, the velocity of the belt. So they have to check all this to ensure that there's minimum deformation of the stamp parts during the transfer process. Okay, this is a GUI, a user interface, right? You will define your stamping parts, then you can set up a different conveyor setting. Okay, from there will be other parameters that involve in these calculations. Okay, this is just one of the example that we did for our customers. Okay, we look at the transport of the body side by the conveyor. Yeah, so then you can check before dropping and after dropping, there will be some deformation because of gravity effect and also because of the impact, because the sheet metal is quite soft and then it's also heavy. So some of the area might be deformed during the drop process, right? So that's what our customer would like to see. And they also like to know if this part will be moving or drop onto the ground, because of different conveyor setting, right? I have also another example right here with this example. So because this is a long and flexible part, so during the transport process, you can see that the parts being deformed. All right, so that's what happens. So in this case, they will be able to modify the part structure to ensure that it stays rigid, during and after the drop process. So this is one of the objectives why we are conducting this kind of simulations using Dynaform. Okay. So now I like to go over some quick demonstrations, okay, of our features. One of them is blank size engineering. Okay, so in this case, we have BSE. All right, so when you start a new BSE project, a batch BSE project, so you can create these new projects and then pick batch BSE. Then you can import your assembly, the part assembly. Okay, the whole thing takes about a few minutes for you to operate. All right, and here it's reading the part geometry. Okay, what's taking time is the calculations. If you have more part geometries, then this process will take longer time to read your part geometries. Okay, and this might take 5-10 minutes if you have a part geometry of over 100 components. All right, like a full vehicle assembly. Yeah, that might take a long time. So in this case, we have around 10 components for a module. Then we can, all this material information is automatically defined because we already defined the path of your Excel spreadsheet where you keep the material information of each part. And what batch BSE will do is automatically create the nesting report for each part and then export the report in an Excel format. So in here, you will see that batch BSE is running calculations for each part one by one. Okay, so I'm gonna move this. Okay, so at the end, you will see that we can output this to a Excel report format. That will save you a lot of time, okay, for creating this report manually. Okay, and the report include the part geometry and different type of nestings and with different utilizations, right? So you can tell, what is the material utilization for each part using different nesting options. Okay, of course, you can also go into manually modify the condition of each nesting part, right? This is also included in batch BSE. Okay, so the next demo I want to show you is the SCP. Okay, in here, you can set up a spring back compensation project in Dynaform 6.1. Okay, this is a simple example of an X-rail. Okay, so we will use the simple formability simulation module to set up in the draw process. Okay, and you can animate, the stroke of the tools to confirm that the stroke is correct. Next, you can click on the SCP tab to define the master tool and then select the options for compensations. Okay, and you can also define the iterations. Okay, the number of iterations will be set by the user, and then you can move on to submit the simulations. Okay, and This simulation includes the forming simulations, and spring back compensation will be conducted at the end of forming simulations. So it will take some time for this to run the forming simulations. Okay. Then we'll have spring back calculations here. All right. At the end of spring back calculations, then we will continue with the compensations. Okay. So I'm basically fast forwarding this so you can see that. And now we are running the compensations. Okay. So now at the end of compensations, you will see that you can plot the results, okay, in here. So you can view the results, you can show the contour, okay, show the contour, okay, of different iterations here, because you selected 3 iterations, so you have 3 different results. And then you can click on here to check the deviations. All right. So, okay. So that's the end of the spring back compensations. We also have blank and trimline developments. Here, I would like to conduct a live demo and let you see, how easy it is for us to set up, blank and trimline development projects. So from here, I will click a new project. I like to create a new sheet forming project. So let's say this is trim development project. Okay. I'll click OK button. And then this is a simple crash form model. So I will create the crash form, and they have 2 different operations. I will create 2 operations and then click OK. You can click and drag this and place it here, or you can use the plus or the cross button to add or remove the process. Okay, and we click OK. Here, all this red coded font means that we have to define it. Okay, we can set up the project parameters, in this case, project informations, or the accuracy of the simulations, all right, or the type of elements. Now we support shell, thick shell, and solid elements. All these are supported in 6.1. So, and then you can also assign a user-defined press coordinate system. All right, it's also supported here. And then in your tool offset type, they are either geometry or contact. Geometry offset is for physical tool, where the gap of the toolings is already being offset in the design. For contact offset, we are using one side of the tool and then use it contact offset numerically. So you will not see any different when you look at the physical tool, because basically there are no offset between physical tool. Okay, so in this case, we will use the contact offset, and then I can go to define blank, click to define blanks. We can click the define blank button here, define outline, or we can go to geometry to set it, right? In this case, I can click on the geometry and then import. Click import to select. Okay. First, my blank outline. Then I can import, or I can import and select all of them and click OK. All right. So all these things will be imported into Dynaform. All right. We can manipulate the tool display by turning on the light bulb here, or you can select the green button here, right? These are on off to show or display the components of your geometry. Or if you have the curve right here, you can click on the curve and then show or display the curve, right? So it's available here. So we have different options to display the geometry or the lines being displayed in Dynaform. Once we have this, we can go to define blank, and here I can click define blank, right? Add the line. I have the blank outline here, just one. Once you click it, it's being highlighted. Then we click OK, then exit. So at the end of it, okay, it's being created, but I believe we put a default value of the mesh size of 32. That is quite large. So I'm going to change it to 6 and then click apply. But before I do that, I'll let you see it. You can still show your mesh, the elements. All right. Now, if you change to 6, then you have a much better elements, and your calculation will be much better. Okay. So, all right. I think I just pressed the wrong button and I missed that. Okay. So after I create the blank mesh, I need to create the material. Okay. I can click the undefined button and select from, let's say, the European libraries. This is not the whole things that we have. I believe DYNAmore have a very special material library, and they are providing it to their customers. So you need to contact Peter and his team for that material library. But for ours, we do have some of the material here, but there are also some material, if not covered in this library, we will be able to provide to you privately. Okay. So we can click OK for this material library. Now I just show my blank and then hide the mesh. Next, I will click the punch and select the punch. Okay, this is for the punch. Then click include. Okay, then exit. Okay, so you see the stroke is 800 here. It's maybe too high. I can change the stroke to 200 or 100. In this OP stage, you can change it. I forgot to change that, but we changed the stroke, and then now we will define the die. We click the die of the same geometry, because we will have the contact offset being defined automatically. Okay. So now, because we changed the stroke, we set this up. So you can click on this play or animation button on the upper right corner, and then we'll show the animations of this process. Okay. So exit. Now I can go to define the OP20, where I need to define this die, and then define this same thing. Okay, so we set this up. You notice that the stroke is also 800. Then you can go here, select the OP20, and then change the stroke, let's say, to 200. Okay, and set it there. And the reason we put it here, because in the future we are trying to provide more press related parameters, so the user can relate this to their press in their factory. Okay, so once we set up the forming process, we can click on the trim line developments, and here we can add. Okay, we can add the trim line and the target line. Okay, you can create one. Let's say I want to add the target line. In this case, we can pick the target line, click OK. All right. You have option of doing the optimization by localized regions. Okay. In this case, we want to check the whole, but if you want to localize the region, then you can check this box, all right, and select the region where you want to check the optimizations. All right. So we have a target line. Now I need to select the original line. Okay. In this case, all right, you can select the curve here, which is the outer line of the blank. Then you can click OK. And you have the outer line. This is your reference. If you have some holes, okay, if you have some holes in there, then you can add more. You can add more. Okay, lines in this, you can add several of them. It's no problem. You can click add. All right. In this case, I don't have it, so I can just delete it and just keep the one item here in the blank and trimline development. Okay. So once this is done, you can move to set the parameter, like what is the number of iterations, for this trimline development. Okay. Usually, we take 3 to 5 iterations. All right. Although we just list as a 10, but in our past experience, we get this done between 3 to 5 iterations. Okay. So you can set this. I set it to 5. All right. And then you will start the iteration from 0. Okay. So you can set that. In some cases, a customer will have some guide and pilots. Unfortunately, this feature is not yet implemented. All right, so we will implement it in the next versions. If your blanks outline is changed, then the pilot or the guide will be automatically moved closer to the blank. So you don't have any problem when running the subsequent simulations during the trimline development process. Okay. Once this is defined, then you can click jobs, okay, and then select the trimline developments and then submit the simulations. Okay, so this is the whole process of setting up blank and trimline development. Okay. Oh, by the way, you can also check these animations to look at both process. All right, if you want to check, there are 2 processes. You can check that, if the animation is correct or not. All right, so that is the end of my demo. So for blank and trimline development, and also SCP and batch BSE. So I like to move to our next, which is Q&A. If you have any questions, you can type in the chat box, or you can raise your hands. All right.
So thank you very much, Jenson, for the very nice presentation. Well, I think it's very promising, yeah, because of course the trimline development is very important to our customers, and many of them are waiting for this feature in the new graphical user interface. So as Jenson already said, you have now the chance to ask your questions either by using the chat function of WebEx, or just raise your hand and we can unmute, or you can unmute your microphone and ask the question.
It can be in German, right, Peter?
Of course, it can be in German.
Okay.
Of course, it. Yes, you're also welcome. So, falls Fragen da sind, gerne auch auf Deutsch, natürlich. Natürlich haben wir auch die Möglichkeit, Sie können die Fragen dann auch direkt an uns senden bei DYNAmore im Nachgang zu dieser Veranstaltung, und wir würden die dann auch gerne im persönlichen Gespräch klären. Okay, also es sieht nicht so aus, als kämen Fragen. Okay, so Jenson, obviously there is no question.
Yep.
So your presentation was so good that everything seems to be clear now. You told us already that in November you're going to release this version of 6.1. Okay.
Yes.
So, and all of those features will be included, yeah?
All the features presented here will be included, including the drop test. All right. However, drop test does require additional license. All right. So not a lot of customers will have that. Yeah, but basically for blank size engineering and for mobility simulations, all the features that I presented here will be there. And there are also some that I didn't present will be there too. As I mentioned, we have about 90 features in this 6.1. Okay, 90 features, right? Including some bug fixes, but altogether about 90. Okay, and I just show you some of the significant one that require a lot of work from our development team. Okay, so that's why I presented it here.
Thank you.
I cannot tell which date yet, but I think we are getting very close. I hope it will be before Thanksgiving. All right, so like the 3rd week of November, and that's what I'm expecting. We should be have it released to our customers. But for you guys, all right, I think we will be able to provide some beta versions. All right, in early next month. If you're interested, let me know. Okay, for DYNAmore.
Of course we are.
Yeah. So you can tell us what else we need to improve. Okay. Yeah.
Great, thank you, thank you. Well, I have a question. So if there isn't any question out of the audience, then maybe I can ask you a question. So you showed that you're supporting not only shell elements but also solids and thick shells.
Yes.
We know that we need different settings in LS-DYNA for the different element types in terms of setting contact features or something like that, or similar things. And will this be done or adapted automatically in Dynaform, or how can we proceed to just to be sure that the right settings will be used for the simulation for each element type?
Well, in the past we've done it semi-automatic. Like some features, it's being implemented for solid elements. But not everything is automatic. So perhaps you can help us to check if things that are not being implemented automatically, when you pick the solid element formulations, right? What are parameters that's not changed automatically? Then you can let us know, right? If there are maybe other parameters that we might miss. Right?
Okay.
Ideally, everything should be automatic. Users should not be worried about the parameters. Right?
Really, yes, I agree. Yeah. So I think not every material law supports solids in LS-DYNA,
yes,
and we have different contact settings, as I told you before, and I think this should be mainly be done automatically. Okay.
Yes.
Okay. So if there still is no further question, I would like to thank you again, Jenson, for your support and for your time and for your very, very nice presentation.
Thank you, Peter.
Excuse me, can I have one question?
Of course. Yes.
I would like to ask about the licensing for the Dynaform. Currently, I'm from Whirlpool. We have around 44 licenses for LS-DYNA. But do I need some additional license to use the Dynaform?
Yes, you do. It's separately. So there, this is, well, Dynaform is the pre and post, and you need a separate license for that. Yes.
Okay. Thank you.
You're welcome. But if you want to test this, no problem. We can provide you a test license as well. Yeah. Just to give you a clue of how Dynaform works.
Actually, I am some occasional user for this forming simulation, so I was using that in LS-DYNA before, but this seems to be a nice tool. But personally, I don't do so many forming simulations, so I don't know whether it would be making sense for us to buy additional license. So this was just my question in case I will be doing some simulations in the future as well.
Okay, so feel free to contact me directly. Yeah? So if you need a license or just want to get an impression of Dynaform, we can show it to you. You can use it. You can test it. No problem.
Thank you very much.
You're welcome. So, are there any other questions? If not, then I would like to go one step ahead. So Let's come to my colleague Matthias. I introduced him already in my welcome talk. And as Jenson already told in his presentation, that we at DYNAmore, we do have some additional material cards, yeah, for the usage within Dynaform. And Matthias will now show those new materials and how to include those materials into Dynaform. Okay, so Matthias.
Yes, I'm
please.
there.
You are there. So now I'm going to unmute myself. Please go ahead and start your presentation.
Okay, thank you, Peter, and also thank you for the nice presentation, for the nice introduction. Good morning. My name is Matthias Merten, and I'm a simulation engineer here at DYNAmore, especially for forming and production processes. And today I would like to give you an overview on our new material libraries, especially for Dynaform. So therefore, I like to point out some background information and of course, the most important information, how you can get these material cards. And at the end of my short presentation, I will give you some live demonstration of how they look in the new Dynaform version 6. So the materials, or the material cards itself came from a cooperation with the Austrian steel producer voestalpine. They provide us test data, and we created LS-DYNA material cards based on this data, especially for forming simulation. The data provided by voestalpine also contains several forming limit curves. In addition, together with the company Edelstahlmechanik, our colleagues from the Material Competence Center did some material calibrations for stainless steels, and so we also can provide 4 material cards for stainless steels. All of these single cards available were combined into a ready-to-use material library for Dynaform. So how you can get these libraries? First, you should visit our homepage and navigate to Products and Material Cards. There you will find the contact data from our sales department, and if you write them an email, they will send you back a license agreement. You have to sign that. Please note, the material cards are free of charge, but we need a license agreement to ensure that everything is correct and so on. And if you send it back to us, we will provide you a download link, which will lead to our file sharing system. Here you can find 2 folders. The first one contains the original data we had, or where we had every single material card stored in the, let's say, LS-DYNA format. If you are an experienced LS-DYNA user, you can use these material cards. If you use Dynaform and you want to have these material libraries, you can download this zip folder and unzip it. If you do so, you will find one folder for the Dynaform 5.9 version, which still is productive, and of course also for the Dynaform 6.0 version. In addition, there is a small installation guide. Please note, during the installation of the material libraries, you require administrator rights on your computer right now. If you did everything which is written down in this small installation guide, you can achieve the material cards in Dynaform. And now I will show you how this will look like. Therefore, I choose, no, not yet. If you download this folder, it looks like this. And here inside are all the material data. For example, this material voestalpine. If you go here, you can find all the material cards, and inside each material card, there are some further information. For example, this disclaimer. This is quite important. Please read it carefully if you use the material cards, and also some other information. So if you know LS-DYNA keywords, you are quite familiar with this layout. If you did this, you have access. Oops, sorry. Wrong button. If you installed everything, you can go to Dynaform and as Jenson presented before, the whole workflow and so on, you can now choose a material. So if you click on Material Library, you can choose from the different pre-installed material libraries like Europe or China, and also between the additional libraries provided from us. So now I choose the first alpine material. So here you can see which materials are available in this material library. There is a bunch of materials, and their naming is with respect to the current VDA standard, or mostly to the VDA standard. As many materials are known under other names, we add the other names here in the remarks too. So for example, there is this EN label, or there's also a common label. For some steels, these makes it different. For example, if you take a look on these CP800 steel, these material cards contains also informations about the coating which the material has during the testing, and also some background information for the FLC creation. There are two methods available to create an experimental FLC. The first one is an ISO standard, and the other one is a so-called time-dependent method. For many materials, we have FLCs obtained by both methods. So I decide to provide you both as one material card. So as you can see, the flow curve is not changing, but the FLC is changing. So it's up to you to decide which material is, or which curve is better for your purpose, or which method you trust more. I try to name the materials that you can easily make a difference between them. For example, you have this TDM inside the name, which is a hint for the time-dependent method, or an ISO for the ISO standard. Additionally, I add the thickness in the material name, where you can see, okay, the FLC was created for such a thickness. For some of the materials, we have more FLCs for several thicknesses available. So if we go through this, you can see many materials. And also several coatings and so on for each of them. And yeah, if you use a material, these stored information, for example, this FLC curve, can be or is directly forwarded to the post-processor. So in this tutorial example, I already calculated it. I'm sorry, I have this WebEx slides on the top. So if you go to the formability plot and animate the result, for example, and go to the last one, you can note here that this formability curve is the one provided by First Alpine. And now you have the chance to unveil the design flaws of your material based on the experimental FLC and the given information. So here we can see the crack. Okay, so if I switch back to the material lab tab, I also want to mention that you can activate the calculation of the formability index if you have a forming limit curve given. The formability index is a number which gives an information about how much of your formability is used. And this is especially helpful if you have nonlinear paths inside your sheet metal forming. You know, these curves are just valid if you have a constant factor between both strains, but if you change the strain path, this curve isn't valid anymore. Therefore, you can use this formability index to calculate how much formability you use or you consume on every strain path increment. If the final number of this formability index is below 1, you know, okay, there will be no crack. If it is above 1, you can assume, okay, there will be a crack. And this is much more better if you have non-linear paths inside your forming simulation. So yeah, I think I'm done. This is a new material library. So if you are also having materials you can provide or you want to have inside such a library available for Dynaform users, please feel free to contact us, and we then can create such a format that Dynaform users can choose from your materials and make their simulations with your material data. And yeah, so I think I'm done with that. Are there questions about these material libraries? So this is not the case, as I see.
I have a question, Matthias.
Yes, Jenson.
Yes, your library here. How many material models considers?
Yes. Currently in this first Alpine database, we just have material 36 available, and I think these stainless steels also have MAT 133, but it's currently not supported by Dynaform 6.
Yes. Would you be needing other material models?
I think so, yes. There are some.
Yeah, please let us know.
Yes, of course. I will send you a list.
Okay, because we also don't know what else needed, That's why I'm curious, because you have the raw material data from the the steel maker, so you may be able to consider other material models that we don't support yet.
Yeah, our colleagues from the Material Competence Center decide to choose MAT 36 as this is the most common one. But for example, if a material supplier has their own laboratory and their own material creation department, they may know best which material law fits best to their material. So we also would need their information. I know, and I've seen that you support now also the Tata Steel FLC.
Yes.
For example, MAT 136 is one material I would like to see in this database, which is the vector material, which you could call also Tata material, as they provide their data in this format for their material card.
Yes, the chorus vector material. Do you have the parameter for that too?
We can create them, but they are also preparing it to provide them because they have the material parameters because they did the testing and everything. But we need to support the material that they can provide the data because it's something which comes first.
Okay. Yeah. I'll keep a heads up,
Yeah.
So I remember that because it was implemented many years ago in LS Dyna. I requested that.
Yes. I already add this to our seminars because it is, let's say, quite underused in LS Dyna.
It was requested, I think, at least 10 years or 15 years ago. Underutilized.
Yes, and that's why I make some promotion for it in the seminars. To make it known by the users and to increase the, let's say, the user base of it. So that's why we decide to stick with MAT 36. But if others are requested, I think we can also do this with these data. And if other material suppliers or producers can provide their data, of course, we need to know in which format it will be, that you can support it by the user interface, and we can create, for example, the library for it.
Okay, good. Thank you.
You're welcome.
So thank you, Matthias, very much for a very nice presentation. So are there any other questions? Well, we saw that there are a lot of different material data, or there is a lot of different material data. And if the customer does have problems in choosing the right one, of course, you're very welcome to call us. Yeah, and we're going to help you choosing the right one, just to avoid some difficulties. Okay. So we are perfectly in the time schedule.
Thanks.
Well done.
Yeah.
So is there something else, Matthias, you would like to show us?
No, I'm just clicking through the different materials, but yeah, you can take over the presentation if you want.
So I try to. Okay. So I hope you can see my screen now. Then you should be able to see the agenda. Then you can see we are almost done now. So I think we saw two very, very nice presentations. And again, thank you very much to the two speakers. I think we got a very good impression of how the new Dynaform 6 version looks like, and about the new features of 6.1, which will be available hopefully at the end of November. Additionally, we saw the presentation of Matthias with the extension of the material database in Dynaform. We know that it's sometimes it might be a problem to have the right material data for the corresponding simulation. So with this extension, we hope that we can help you just to go ahead and do some additional simulations. Okay, so if there aren't any questions anymore, then I would like to close the session. Again, I would like to thank you very much for your attention. We kindly ask you to evaluate this session, of course. We have to add the link into the chat. So we are going to send you to send you a link to the evaluation survey, and then you can go there and just tell us if you like this kind of presentations or webinars, or if you do not. So the slides also will be uploaded to our webpage, and the recording has been recorded and will be uploaded to the YouTube channel. And if you have any questions, please feel free to contact us, either us directly, Matthias and myself, or to support@dynamore.de, or take a look at, of course, our well-known web pages, LSDyn examples, papers. We have some hints or frequently asked questions, and also manuals. So with these words, I would like to close the session. Again, thank you very much. Stay healthy.
Thank you.
And yes, I'm looking forward to see you at the next webinar. Okay?
Everyone stay healthy. Thank you, and enjoy your lunch.
Yes, you too. Thank you. Again, Jenson, thank you for your time.
Okay, bye-bye.
Bye-bye.
Thank you very much. Bye-bye.